Hi, how are you?
Hi. I'm good. Thank you very much. How are you?
Well, actually good, but I had some problems with homework, so I just maybe needed to suggest maybe just one consultation about our previous homework task. Because actually, I think I don't know some Python functions. I spent not too much, up to 2 hours, but I didn't figure out how to solve the issue with subplots with wrong identified images. So.
Okay. I think if Olena will join us today, I think it kind of makes sense if we somehow, I don't know, maybe have a separate call that we could discuss these issues. Yeah, I think she had a lot of similar troubles actually, and maybe if somebody else wants to join in, then I could.
Or maybe if there was a permission just to maybe organize a group internally, just to exchange, I don't know, ideas or solutions.
Yeah. I think that's why I think I created Slack just for this purpose. So you guys just have a channel together with you and just talk about these things. Absolutely. And yeah, let's talk about, I mean, give me a chance as well to explain. Today I'll actually focus a lot more on coding. I mean, I try to make it as easy as possible, but the part that is there, I try to explain as much as possible. Okay, so that we actually focus on that a little.
Okay. Thank you.
Do you have Slack right now?
Well, on phone, but I will install it on my computer I think in several minutes, so it's not a problem.
Okay, I just should I send all the links from the Slack, this lecture slides, the notebook, and whatever other thing was there?
No, I don't think so. So I will manage this.
Okay, gotcha. Good. Hey, Simon, Alexander. Hey. All right, so let's see. Kenneth is also here. Great. I know that Elena wanted to join. Don't know if we should maybe wait for a couple of more minutes because that's just super crazy in Canada. How are you guys? So I saw that Oleg, you have submitted your homework, right? Did you?
Yes.
Okay, how was that? How complicated?
I wouldn't say that it's too much complicated, but volume is big enough, yeah. So yeah, I let's say maybe also didn't let's say have enough time to achieve this good statistics, yeah, for for this regression New York taxi. Yeah? So I did first improvement using decision tree solution, yeah, with some additional preprocessing, additional feature engineering, but just run out the time to try the rainforest. Yeah, this
rainforest. Okay.
Yeah, rainforest. Yeah. But,
no, but
in principle,
so what you're saying is like, it's like challenging but doable?
For me, yes. Yeah.
Okay. Simon, what about you? How did you feel?
Hi, I'm very sorry, but I was confident the deadline is 31st.
Okay. But so the deadline was yesterday.
Yes,
but that's fine. You have late days. You have lots of late days.
Yeah, I have. Yes, thank you. And could you please remind how much?
Yeah, I will. So I'll give the first lecture slide. Basically, it's about deadlines. Okay. I think we have 7. I think it's on the Moodle page. So if you go to the course page, I think all the instructions are there.
Okay, thank you.
I think it was 7 late days for in total. So you still have time. Did you try it? Have you attempted?
Yeah, I was busy with the business issues. That is why
Sure.
I thought 31st is the deadline. Sorry.
Sure. That's why I gave this late days, because I think it makes sense for everybody to have some luck. Kenneth, how are you doing?
Not too bad. I'm finding it challenging, the technical aspects of it. Yeah, but I mean, I'm here to be challenged, so I guess that's.
I love this attitude. I also here to be challenged. So please challenge me once you feel like there is something that is unnecessary, challenging. Please challenge me instead. So
one thing that actually I think might be useful.
Okay.
Is I know there's the idea to Google things and you don't know what to do them, but I mean, Google is a large landscape.
Yeah.
Are there more narrow places of reference other than just searching the whole internet?
I would say that I will basically today's practice session and tomorrow's, I'll basically dedicate to mostly how do I solve myself challenging programming problems. So I know what I want, but I don't know how to get there. So what I do to get where I want, but not knowing how to get there. Mostly, disclaimer, mostly I do Stack Overflowing.
Stack Overflow,
yeah. So, but I mean, there is some subtle art in knowing what exactly to try and what not to try, because some things, they seem okay, but they are not. They're a bit misleading. So I'll basically focus today. I have to make a confession to all of you guys. I'm very bad programmer, right? I'm super bad at programming. So what I do, I just Stack Overflow, and then I try to glue together things that seem to work for my case. And then if they work, I'm happy. And that's pretty much it. So you are in a good position. We are in good position. So I'm not programming Nazi in that sense. So I will be forcing you to write classes, object-oriented programming, all this kind of paradigms of programming and all that kind of stuff. So if it works, happy with you. So yeah.
Yeah, because I mean, in a previous lecture, we had like a tiny little window into like how you do things, where you were like, you built it up and you were putting test points inside the larger thing. And I think some explanation of kind of about a bit how that works would be useful to have some kind of approach.
Yeah, sure. So I think I try to catch up on this one today and tomorrow. I think it was a mismatch of my expectations. I somehow assumed that you guys like the programming is not something I should be focusing on. So I was like, basically scratch the programming. We are now here talking about machine learning. But I guess it makes sense to somewhat look into programming exercises by itself, because it's by itself is an interesting problem. Like, how do you get from nowhere to having a list of things that make sense? I think it's a very good comment. So let's see how it goes today. Olena, good night, right? So are you with us? Can you hear us? Can you speak?
I can hear you, but I'm not sure that I can speak clearly.
Oh, don't worry. Please speak in whatever tone and voice, whatever you like. So until I understand, it's perfectly acceptable, and everybody else understands. So it's perfectly acceptable. You can see that many people had troubles. So it's everybody is there's a struggle here. So I try to alleviate you guys' pains regarding programming. So let's see how if I manage today to help you to somehow alleviate this problem. Right. So let me go to my lecture slides. First, I wanted to tell you that I got really sick in the beginning of the week, so I couldn't finish Timeseries lecture. I still plan to do it by next Friday. So this is what the change in the schedule has been. I'm not sure if you've been told already, but we'll have today and tomorrow. And instead of Sunday, we'll have a lecture on Friday. So the Timeseries lecture will be on Friday. Yeah, June 5th. Yeah, June 5th, if I'm not wrong. Timeseries turned out to be a hard nut to crack. I looked through gazillions of sources over internet, and it seems like this was so far this was a land of statisticians who were kind of running in the wild field and drawing formulas like this. So this is a formula that was sent by a colleague of mine from Ukrainian Catholic University that teaches time series course in UCU. And I just came along and I said, hey, you know what? I don't get this little tiny thingy here. Like, how do you really make it work on a very small example? And then he drew me this kind of joint distribution of this kind of that. And then you optimize with respect to this and that of this kind of formula of the product of infinite number of blah, blah, blah. And I realized that there is a land of opportunity in time series. So, but it's a challenging one. So I'll try to make it more clear by next Friday. All right, so you should see my slides by now, I hope. If you don't see my slides, please voice it up, tell me. But this is our, what is it, fourth lecture. It's a fourth lecture on machine learning. So the course is called Advanced Machine Learning. And this lecture, in my opinion, is basically explaining why the course is called Advanced Machine Learning, because there is advanced bit comes along. But today's part is not going to be advanced in any regard, in any way. So we'll be looking through very basic ensemble learning techniques. But before we go on, there are a couple of things that I want to say first. One thing is that I'll be giving homework number 3 today. So I'll be basically giving out homework number 3. The deadline for homework number 3 is June 11th. So if you guys don't, if you don't remember the deadlines, I think I have written them on the course webpage, but if it's not true, then I will today. And if it's not true and I won't, but you still can find these, the table with the deadlines, right? It was an organizational slide. So you have the link to the slides, so you can just open the slides and you can check out the deadlines. And plus each assignment has deadline. So when I open assignments, you can also check out the deadlines. But I'll just in case, I'll duplicate the deadlines on the homework webpage. The time series lecture I already mentioned. So the deadline, so we are going to have it next Friday, June 5th, the time series, Predicting the Future. So finally, after studying machine learning, business, economics, and whatever, you will finally learn how to predict future. And that's the point, looking into the future, saying what happens in the future. In the meantime, what happened previously? We looked at overfitting, right? So we looked at the different ways how things may go wrong. So we checked out what happens if the model is learning on the training data, but it's not learning on unseen data. And we specified there are could be two possible reasons for this. One is something wrong with the data, and the other one is something wrong with the model. Does anyone remember what was the reason that the model? What's the problem with the model? What could be the problem with the model? Oleg, what would be the problem with the model?
The problem with the model could be that it's overfitted.
But why it is overfitting? So I'm just saying here that it's overfitting because of the model. So what problem of the model is causing the overfitting?
So the problem with model, let's say either we have too many features, yeah, and in this case, then we use this first R1, yeah, regularization 1,
yeah,
and
L1,
L1, yeah,
or
and
L2.
yes, and or let's say we need that our model works. So the problem is that our model could be perfect on training set, yeah, data set, but it could not good on the test data set. And test data set is data set from real life, let's say, yeah.
Yeah.
And that's why we want to achieve the good, smallest error on test data set, yeah, from real life.
Yeah.
That's why we make some kind of penalty, yeah, for perfection.
So basically, way A is to penalize the model, right? The problem is the model is too powerful. So it's powerful enough to learn things in the training data, but it still has no idea what is happening in the test data. Olena, what could be, so the way A is what we were discussing with Oleg is that basically there is something wrong with the model. And the second way to look at this problem is that, well, there is something wrong with the data. What do you think is a problem with the data? What do you remember from previous times?
I don't know. So we can do cross-validation for data to.
No, we can do, but what's the problem? What is the initial kind of what is it that causing the model to overfit? What are the properties of the data that are basically somehow make model overfit?
I don't know, too small data set can do.
It's just too small, too homogeneous, right? So you have like two cats, basically pictures of two cats, and then you have test set with dogs and ostriches and whatever lions there, and you're trying to detect these, but you actually have only two cats to train on. So the data is not sufficient, right? So there is not enough data. Yeah, so we've discussed both of these ways. And actually, both of you guys, thank you very much. You just gave a short intro into the future slides. So basically, we were saying that explicit regularization techniques is when you explicitly limit the model creative capacity, right? And we were just saying, well, Oleg was just saying that, you know, this is just L1, L2 regularizations. There is another one explicit, which we studied, was dropout. By the way, Semyon, do you know who is this guy? Who is this guy? The guy? I mean, this is obviously the Wonder Woman with the lasso regression. She's doing lasso regression. But who's this guy?
This guy invented dropout.
No.
No.
No, that's close. You're thinking in the right direction. But wait. Okay, let me start again. So she is a Wonder Woman and she's doing lasso regression.
Okay.
Okay. Now you're saying, who is this guy?
He drops out something.
No, she is fine. She's doing lasso regression.
Yeah.
I'm not asking about her. What is this guy? What this guy is known for?
I have no idea.
Okay, that makes sense. Kenneth, do you know who? Can you propose who is this guy? Can you guess who is this guy?
I don't know. His last name is Dropoff. I have no idea.
Tropov. That's nice. No, but his last name is Tikhanov. Because he's the guy who invented L2 regularization. So she's the one who does lasso regression, which is L1 regularization plus linear regression. But his name is, I think it was Alex. I don't remember exactly, but surname is Tikhanov. And he's the guy who invented L2 regularization, and which is part of ridge regression. Anyway, so this is about explicit regularizations. And Olena just told us about implicit regularization. Well, she hinted towards implicit regularization, which was, Olena, can you capitalize on your hint and just, you know, nail it? So what's the implicit regularization method that you were kind of hinting towards? That what is it that you can do to the data to make it work?
Cross-validation.
Sorry, you seem to have the silver bullet. You discovered the silver bullet. So you get basically every question I get, you just like cross-validation it. No, but there's something else, something that you were kind of getting into. You were getting close to it. You were saying there is something bad with the data, but there is a method that helps you to get more of that data. Igor, are you with us? Can you help with that?
Let me be like Elena.
Okay.
I would actually, I like that silver bullet with cross-checking, but no. Here we can add, we can clone data with small changes
Exactly. Small variations, right? How do you call this thing?
Augmentation.
Yay, Lena capitalized it, but she,
I didn't.
yeah,
I
she
didn't.
just said it. So it's exactly as you're saying, right? So you can clone data with the small changes. You can change saturation levels. You can rotate. You can flip. You can do whatever you like. There are tons of ways. So, for example, there is a library called ImkAuk that, if you're lucky enough to work with images, you have tons of ways to multiply your data to get a lot of data just from one image. So this is all just one image made different for the model. So it's a truly Eldorado for data management. So you can get a lot of data.
Is there no downside to that? I mean,
Oh
really,
yeah.
it's as good as that. It's just.
So you're saying what's the downside of this?
Yeah.
So you can't be like just pulling yourself out of the swamp from your mustache without paying the price, right?
You called it Eldorado, right? Is it really Eldorado?
Yeah. So basically, what's the price? The price is sometimes when you do a lot of these things, you still need some data, right? So you can't just generate lions and ostriches from the picture of the cat, right? So there is no way around that. You can't have one image and then just generate the entire data set from this. Unless you do have generative adversarial networks, and then you make lines from the cat, and then you augment the lines that you get from the generative adversarial networks, but we are not talking about this. And I don't believe in that either. So I'm not sure if that's gonna be useful either. The other downside is that when you have a very small data set and you augment heavily, meaning that you multiply by a factor of 100, let's say you had 20 images and then you got 2,000 images. The value of those 2,000 images is still relatively limited, depending on what you do. For example, if you classify images, then it's gonna be still limited. And the other downside is that not all of these transformations are useful. I mean, you won't probably see in the real world some kind of rodents that are squashed, or rodents that are completely, I don't know, in pink, or somehow turned, and then basically there is some kind of weird noise on top of it. So basically not all of these are useful for your purposes. And figuring out which ones of these transformations are actually useful is a bit of the challenge, is a bit of art. And that's why people are saying that augmentations do require some of the human expertise and domain expertise to work with. And of course, it's just works for images. This is perfect for images. How do you do this kind of things for text, or even for sounds? It's not so simple anymore. Yeah, that's my take on what are the downsides of this. So there are plenty of. Yeah, I just sorry. I was just basically saying that these are the ways to try to fix things, right? To make your work, to try to attempt your model to make it work better. That's just a couple of things that you can try. There are other ways, right? So it's not just way B and A. There are other ways to make a better performance and fight overfitting. And one of the ways is what we are going to focus on during this lecture and tomorrow's talk as well. And yeah, just to give you a flavor, Avengers ensemble. So this is all about ensembling techniques, right? Getting weaker learners and putting them in a team and making them fight evil, meaning overfitting, right? So the true title slide of this lecture is more like that. We're going to grow trees. We're going to grow forests. We're going to grow forests, and the title of the lecture is Ensemble Learning. As always, lectures of my kind of courses, they start like this. We have 5 points. What happens then is we divide these 5 points into train and test set. For example, we just say that these 3 points are training data and these 2 points are test data. We forget about the test data for a moment. And okay. By the way, please do interrupt. I can't see all of your, I can see 6 cameras, but I can't see all of the cameras. So if just in case, just pick up. So we forget about the test set for some time. And then what we do, we train linear models. We train linear models on the train set. So we take a simple linear model, which has well, basically no regularization, just a linear model. It has an equation 1.6 plus 0.79 times x, which is this is x, this is y, this is what we are predicting, this is what we are using to predict. So this is a normal linear model. Then we take a ridge regression. So we take a linear model with a L2 regularization. We fit that one. Then we use lasso regression. So we take L1 plus linear regression and we feed that one. So we get 3 models, right? So these are the 3 models that we have trained. And then what happens is that we take the test set and we use it for each of these models to verify, to basically say how good is the fit. What's the goodness of the fit of these models? Yeah, so we basically just copy paste these models on the test set. And what are we going to do? We are going just to say, well, that's, we're going to calculate the goodness of these models, right? The predictions for these models. So linear regression, ridge regression, lasso regression. Now, here in this table, I want to calculate the prediction that each model makes for point 1 and point 2. So that's why you have 1 and 2 in the columns. These are basically points 1 and 2 in the test set, and these would be the predictions. Now, Simeon, can you help me with just conceptually, how do I know what is the prediction for the linear model of the first point? So how do I know what is the prediction that linear model makes for the first test point?
Let's take the real value and prediction value.
Which is in that case is
about
4.
4, yes, about 4.
Mm-hmm.
And compare it with our prediction, which is about 3.2.
How do you know 3.2?
I take it from the linear regression.
How do you take it?
Mm-hmm. So I take the line, parallel line across our linear regression and see where it crosses the y line.
Okay, it crosses
the prediction.
Here?
Excuse me. This is actual. It is 4. And the prediction is 3.2, no?
So how do you calculate 3.2? Explain me this one. So I understood how do you saying that this is a real value. So the real value of this point is.
I didn't calculate. You want me to put it in the formula, but I'm lazy in the morning. That is why I just.
You just approximate it.
Yes, just from the graph.
Okay, thank you very much, Olena. Simon has the power. He sees numbers without calculating the stuff. I have no power like that. Can you explain how Simon got this number? I have no idea. He's like, he has a special sensor kind of activity, but I clearly lack that. Can you help me figure this out? How did he calculate 3.2?
Sorry, Olena.
Sorry, Olena, but you know that he's just.
Maybe we need to take 2.
Whoa! That is like super quick. What is 2? How do?
So you have x, and you need to just put in this formula 2 and calculate.
How did you get to?
Just this point 1, and if you, I don't know, go to this linear regression, it will be okay, I don't know.
Oleg, can you help?
Sorry, I didn't follow. Need to answer on working question. So what's the question? Sorry.
So we have a line here, line equation here. 1.6 plus 0.79 times x. And we asked Simon and he was like, the predicted value for this point is 3.2. And he's like, yeah, I just know it. So how does he know it? How did he get this?
It's amazingly good at just quick visual math. It should be
yeah.
0.79 times 2, because we take the value from the 0.1 plus 1.6.
Wait. That's too fast again. So where did 2 come from? What is the 2?
So we want the coordinates for that value, where the number 1 is. And so the coordinates of that are 2 and 4. 2
and 4. So
two,
x value for this point is 2, y value is 4.
Yeah. So if you multiply it out, 0.79 times 2 plus 1.6, you get 3.18.
Yeah. So he was very close, right?
Pretty darn good guess.
It's pretty cool, right? So if it would be 0.8, he would be exactly on the point, right? It would be 1.6 plus 1.6. Olena, and everybody, just look at this. So what was happening here, I think I have an explanation here. So what is happening here is that we take x values. I'm sorry, I have your faces here and I can't see my own slides. So what I do have here is that the x value for this point is 2. Because if you look at the x value, it's here, and it's here, it's 2. If you put it into the formula, it's 0.79 times 2, which is 1.58, right? And then you add, and you add 1.6 plus 1.58, and then you get 318, right? This is what Simon was basically saying. 3.2. You guys don't bother me with details. This is basically pretty much it. Does it make sense? Everybody, does it make sense? Okay, so I just write it here, right? This is a prediction that my linear regression does make for this 1 point, for the test point number 1. Okay. Now, I mean, obvious question now, Igor, what is the prediction? How do I calculate the prediction for point 2? Igor? Olena?
Okay, sorry. Easily, we should take x coordinate of the point number 2, and just to enter this x coordinate into our magic formula 1.6 plus 0.79 x. So we get let's say 1, 2, 3, 4, 5. So we should get 5 times 0.79 and plus 1.6. I need a calculator to calculate this. So it's like, yeah, 555.
Great. Thank you very much. That's pretty much what I wanted to hear. It's perfect. So it's 5.55. And that is the prediction of linear regression for the second point, right? It turns out that you can do the same thing for the other 2 regressions. We won't go into details. I hope you got it. And now we have predictions from each model of each test point, right? This is it. This is how easy it is, right? Just to substitute the x value into the formula and calculate the sum. That's it, pretty much. Now, what I wanted to show you with all this stuff, is that you can actually get even better results by let's say, averaging. So what happens here is that we look for the ensemble. So ensemble is when you get individual models performing together like a team. So in order to make them work like a team, what we do for each point, we will basically average up their predictions. We take the predictions and we then just average them up. So for the first point, we'll take all these 3 values, 318, 323, and 357, and we will just average them up and we will get 3.32. And the same will happen for the second point. We'll get 4.89. And this would be, so this average is what basically the ensemble of these 3 models would produce for these 2 points. So these would be the value of the ensemble. And the true values are 4 and 5, so we can compare the true values to the predicted values and decide which model has performed better. I guess if you would calculate the MSE or RMSE or RSS, you will basically see that the average has, so average usually performs better than the individual models. Do you guys have questions about this? This is the most basic version of ensemble learning. You have 3 models. You take, in case of regression, you take the predictions of these 3 models and you find average of these. And you treat average of these as a prediction for the point, right?
So this is because obviously there's some idea that the errors of these methods are in the opposite direction from each other. Because I mean,
yeah.
Otherwise,
they're independent.
Yeah. Okay.
Yeah, yeah. So you are right. If we would have identical models, we wouldn't get any improvement. So the models should be different, and the errors should be different. There is even a way to say it. What do I mean by different? There's a way to say that their residuals should be distributed according to normal distribution. But I would say for practical reasons, for practical purposes, if you get different models, you will have improvement when you take ensemble. When you take ensemble,
the idea is that one is overdoing something and one is underdoing something, and you kind of okay.
Yeah. All right. So this is called basic ensemble. But just to make sure, Alena, everything is okay for now. Show me or not.
I don't know. Why do we need average?
Why do you need average? So average in this case is very arbitrary. We just take the simplest function that we can come up with that would just, take all the 3 values and produce something close to what has been predicted by the individual models. We can take other things, and I'll show you how to take other things. So it's just a basic version. It's the first step. You can get into more complicated ways to combine these predictions.
Yes,
there are more complicated ways.
Right, put weights on everything and then start fine-tuning those hyperparameters, hyperparameters.
Yeah, you can put weights on these predictions depending on how these models perform. But this is the next step. The first step is just to assign equal weight to every prediction and just say that I'll ask everybody and I'll just average up their predictions. Does that make sense? Yeah. Everybody, any questions, any comments? Okay. So let's move on. So this is what happens when we are dealing with regression. So what happens if we are dealing with classification, right? So the classification regression a little bit different. And Oleg, what's the difference? Sorry for asking these kind of questions in the morning, but still, what's the difference between regression and classification? Just can you remind us?
Classification, let's say we only sort our data to different baskets. Yeah, it could be binary classification, it could be multiple classification, but with regression, multi-class classification. But with regression, yeah, we let's say work with continuous data. Yeah,
we predict infinite number of baskets.
Infinite data, yeah. So
absolutely. So that's the difference. So we can't do. So yeah, just a follow-up question, Simon. Given what Alexa just said, right? Can we do average? For example, for classification, binary classification, can you do averaging?
Yeah, why not? If our forecast is the probability, then to some extent we can calculate the average of probability based on few models.
Yeah. But what if it's end up having just a label? Can you still do averaging?
No, I don't think we can make the average, but we can calculate the number of predictions. If majority of models predicts 1, then it's 1.
Absolutely. So I prepared the ground. Now I can follow up on that. Right. So thank you very much. This is actually what is happening. Similar ideas can be applied to classification. You basically have 3 models. So here I depicted convolutional models, but it doesn't really matter. Just imagine these are some classification models. Think of your favorite classification model. Should it be linear classifier, SVM? I have seen, Olena, that you have just, at some point you said that, oh, I got sick of this cross-validation algorithm with decision tree. I'll just use SVM from this Stack Overflow post and I'll go with that one. So this is fine. Take your favorite, think of your favorite model, SVM, decision tree, linear classifier. Just think about these three models as your favorite models. And then since you kind of initialize them randomly, there is some kind of variation in the way how they work on the same data. So we assume that they would, that the mistakes that they make are independent in this case. So this is just for myself to have this kind of a backdoor saying that, you know what, they are independent enough. So let's just assume that they are independent enough. And then what we do, we train these three models on the training data. So this was the training data. And then we take a test image, and then we generate predictions from each of these models, model 1, model 2, and model 3. So what happens is that I take these three models and I generate predictions. I just write them down. So the first model says that the test image is a dog. The second model is saying that the second image is a dog. And the third model must say that it's not a dog. So it says that it's a cat. Okay. So what happens in this case is that we cannot really go for averaging. There is no way we can add dog to the cat and divide by 2. We cannot sum up 2 dogs and a cat and divide by 3. There is nothing like that. But what we can do, we can just count. We can say, well, we can take a majority vote. So there are 2 dogs. So 2 models voted for a dog and 1 model voted for a cat, right? And since there are 2 models that voted for a dog instead of 1 model that voted for a cat, then I'll assume that the test image actually has a dog on it. So I basically say that the ensemble has predicted that the image contains dog. And you noted that this is the same image. So I put the same image, the same test image into 3 different models, right? And then I collected their predictions. And then I took the majority vote of these 3. And the true class was a dog, obviously. So we can now go to the notebook. Igor, do you have access to Slack? Should I send the link to the chat?
You should not. I have access. I have just
Okay.
installed Slack on my computer.
Good, good. So let me share my...
May I ask a question?
Sure, go ahead.
In this situation, having several models, and this reminds me the idea of neural networks. So it's really several models. So that's and in these several models, you can even by back propagation, not propaganda. By back propagation, you can adjust weights just to calculate the final output. Is this the same idea, or this my consideration is wrong?
So neural networks. So the question is, if I understood the question, but the question is, isn't that the same from what is happening inside the neural network?
Yeah, just approach.
It's not exactly. Inside the neural networks, you have tons of layers of neurons that communicate. So this, in that sense, it's similar because information gets aggregated in neurons, right? So you take outputs of previous layer neurons, and then you aggregate in one neuron this information, and then you basically shoot it to the next layer. So in that sense, it's similar, but in this very case, which we were discussing in terms of ensembling, then you can actually have 3 neural networks, each one of them having all these neurons inside, predicting the final class. So this is the final model. It's very independent. It's like, basically what you're saying is that when we are discussing, then let's take 3 experts and show them picture and ask what is it on the picture, and then take the majority vote of these experts. you're saying, isn't what these experts, aren't these experts are organisms? Aren't these organisms live inside these experts? So in that sense, yes, these models, whatever happens when we average them up, it's similar to what happens inside neural networks, but these are independent models. So they live independently. These are independently trained organisms that do not really, are not part of each other. They are not somehow linked inside. Right?
Well, I mean, I guess they could happen at different times. Like they could be temporally separated. I could take a predictions result from somebody from last year and two other people, and
yeah, they could. So they could actually materialize at different points of time. Yeah, we could ask Kenneth, can you train one model, and then Elena, can you train another model, and then Alexander, can you train the other model, and then we collect the pickle files, and then we construct an ensemble out of these three, right? So they are not intersected in that kind of sense. Inside neural network, one neuron cannot be trained without training all the rest of the neurons, right? So there is no way we can train the entire network without training this specific neuron. So I think that in that sense, it's similar, but also different. Does it make sense?
Yes,
okay.
Thank you. It's clearly understood.
Cool. Now, ensemble learning. Ladies and gentlemen, just wanted to ask, if you have loaded this notebook yesterday, please refresh, because I have changed some things. Elena, I know that you have done that, because thanks to you, I realized that I haven't given enough access to it. But if you guys haven't loaded this notebook yesterday, that's all good. If you have loaded it yesterday, then maybe it makes sense to refresh, because I have a couple of things that I have moved around just to make it a little bit more fun today. All right, so this notebook contains homework number 3, which deadline is June 11th. Here I also duplicate the deadline just in case. So the June 11th, no, Simon, I'm not looking at you, but just saying that, you know.
Especially for me, thank you.
No, every one of them has this. This is just to, this is a setup. So this is a setup. Igor, I hope you are now the how do you call it? Practitioner of Shift Enter person, right? So only Shift Enter, nothing else. Now, what happens is that we build our humdrum. I'm not sure, Kenneth, is it the Canadian way of saying, but there is this way of saying humdrum example, a very familiar example, humdrum example. Yeah. So we again make it up. We make this example data, which is by the way, ladies and gentlemen, so this is a so-called data frame. I don't know how many of you have experience with R, but in R, this is one of the most kind of famous and popular data structures. So it's called data frame. It's basically a table, but it's a very special table. Normally, so you can think about this as a matrix, but in matrices, if you make matrices, they should all have the same type of things. So if you put, let's say you put strings, so you put words into matrix, then all the values should have strings. If you put letters, then all the values should be letters. In data frame, each column can have different type of things. So you can have a column of words, column of dates, column of numbers, column of floats, and so on and so forth. So that's why we love data frames. And also another thing why we love data frames is that you can actually say, my first column name is X, right? My second column name is Y. And my third column name is whatever I like name, and that would be name, right? So this is the fun part, because you can actually give names to your columns, and then you can refer to these columns by names, which is fun. Okay, so let me run that. Now, this part, again, I don't know how many of you know R, but this is basically a ggplot is a graphics library in R, which makes, in my opinion, the best graphics ever in both languages, programming languages, Python and R. I think ggplot is the best. I have really hard times liking and accepting matplotlib. This is the library that is usually used in Python. That's why I have inflicted all this suffering on you with this ugly, large, and unclear code. In fact, I don't want to teach you ggplot because I think it's out of the scope of this course, but just stay with me and run these cells. They should be, so running this code should not be something that you should really understand. So it's not a compulsory thing to see what is happening here. Just run these code and you will see the graph. Okay, this has 5 points. There is a grid lines that I like and axis names and that kind of stuff. So this code just makes this graph. And if you just very abstractly want to understand what is happening, then this point here, this line here, it makes the base plot. It just makes a canvas. If you know what canvas is when you make a drawing and the thing on which you draw is called canvas. So this thing prepares the canvas. Then you make points, you put points on these. So these points are made by this line. Here I say, this is the color of my fill. This is the wider green. Sorry, this is the darker green. And then I'm saying that I want rim of this size. And I'm saying that this is the color of the rim. And here I'm saying that there is this kind of shape of a, donut. There is a donut shape, meaning that I have colors of different colors of the internal and external. These are the names of the axis, Y and X, just to let you know. Here I'm just saying that X-axis is limited from 0 to 6. Y-axis is limited from 0 to 7. Why they're different, don't ask. It's just the way how things are in programming. Sometimes they are just like that. And this is what makes it looks nice. Theme black and white is basically, look at what happens if I'm not using black and white theme. It has this gray canvas, which I really don't like. So I use black and white stuff. So I get white background here. And this is just to make things look a bit nicer, like the size of the figure and all that kind of thing. So this is all nothing to worry about here, okay? Do you have questions about this? This is just to give you a flavor. What is it like to make these graphs in ggplot? So ggplot doesn't exist in Python, but what exists in Python is this library called plot9. And plot9 is the library that actually imports ggplot from R into Python. So this is basically a wrapper on R into Python, okay? Now, what I want to do is I want to somehow familiarize ourselves with the pandas data frames. So pandas data frames are tricky. I don't like them myself. So if any one of you have hard feelings towards pandas data frames, I completely share that. So here what I wanted to do is I wanted to say, let's take the second, third, and fifth points. So second, third, and fifth, and make them into the training data. So they will be our training data frame. And fourth one and the first one into the test data. So here I just wanted to sample the example data. Can you guys help me sample the example data? So I just typed example data. This is the data that I have just created here, right? Ladies and gentlemen, I hope that you follow. If I would be in the class, I would look in each of your eyes and I'll see if you follow or not. Unfortunately, nowadays you can just hide your eyes and make look like everything is fine. So what happens here is that
it's new feature for Zoom, yeah, with artificial intelligence.
Yeah, I need some kind of algorithm, computer vision algorithm that could predict the probability value of a person detaching from the video stream. All right, so example data, and then I want to say what Kenneth, you're saying, but you're muted.
We're just saying self-driving car attention software probably had built in. You probably have colleagues working on that.
Yeah, actually, you know what?
Are you paying attention
right.
to the steering wheel? Yeah.
I think Zoom has been very rising in terms of the costs of the value. Maybe we should offer something like that. We should say, well, you know what, capstone project for the KSC students, maybe that would be something to go for.
And if somebody doesn't follow, then he gets some rabbit ears. rabbit ears
energy
on
shock.
the picture.
No, that would be too cruel. Anyway, so what my, ladies and gentlemen, can you actually see that stuff? All right, let me make it a little larger here. So example data, let me just add this one split here. So this is what example data looks like, okay? Everybody. So what I want to do is I want to say, can you take this row and this row, because you remember that Python is not like normal human. It doesn't really start counting from 1. It starts to count from 0. So when I say first point, it means 0 point. When I say fourth point, it means third point in this case, in third row. So I want these two rows to be in the test set, in the test data frame, and other rows to be in the training data frame. So what is it that I have to do? My internal programmer says something like that. Put square brackets and then say something like this. Something like 2, 3, 5. Well, we remember that this is not 2, 3, 5, but this is actually, okay, this is 4, this is 2, this is 1. I'm really sorry for that, but these are just the row indexes, okay? And this would be enough. But unfortunately, this is not the way how the pandas data frame works. So if I run this right now, it says, what the hell? Well, it says what the hell on the test set, but it says what? Key error. What the hell is going on here? I don't really understand. So what happens is that so data frames, pandas data frames, they have a special function, which is called iLoc. Don't ask me what iLoc stands for. I think it's somehow related to location, but what I stands
Index
for?
location?
Index may be location, maybe index location, but to me it's fairly hard to understand. And then what is happening here is that I have to say, so right now I don't remember exactly what my code was, so I do online programming with you, and you will have all the errors that I'll have. So we are on the same footing. So you can see what happens if I get into trouble, really into trouble. When I program, I get into trouble. This is what happens when I get into trouble, what I do when I get into trouble. So I kind of think that I know that the first part of this is indices of rows. So the first value are the indices of rows. The second value are the indices of columns. What happens, Simeon, when I want all indices of columns? For example, I want both columns to be in the training data. What should I put?
2 points. I don't know.
2 points, exactly. This is basically saying from start till the end, all included, okay? Now, okay, so Oleg, what would be the result if I would run just this line here? What would be the result? What would be inside training data frame?
We will take a subset of the training data frame with first row. Sorry, with the second row, and all columns will be included.
So it would be 2 and 4. Let's test this, ladies and gentlemen. What happens is that we test. We just print out the name, and we run the cell, and we see what happens. So what Oleg said, that we'll have 2 and 4, and this is what we have. We have x2 and y4. So this is not what we are interested in. This is not what we want. Simon, okay, Lena, what happens if I put semicolon here? Colon here after 1. So now we just had 1, and we got just second row. What if I put a colon here? 2 dots.
Error.
No, not error.
Like why?
Because what basically this notation is saying that from 1 onwards.
Yeah, but I just tried it. I get error, so I need to put in another bracket inside.
I don't have error. So just make sure that the brackets are closed. Then you wouldn't have an error. So this basically says from first row onwards, second, third, fourth, and fifth. What if I want to have only second, third, and fifth, not fourth? Simon, what is it that I have to do? Oh, okay, Igor, what do you think I have to do? Do I get to get second, third, and fifth samples?
Igor is offline for 20 minutes.
Yes, he dropped the message.
Sure. Sorry. I haven't seen that. Sorry. I'm in the fire of explaining. I can't see. I can't read English. You guys. So what should I do? Kenneth, what should I do? I want to get second, third, and fifth.
Is Kenneth available?
I don't know. Is he?
We
Lena,
lost Kenneth.
we lost Igor. We lost Kenneth. Oh gosh, what is happening here? We need the system with the short. No. Okay, let's not get into this. Lena, what is happening? No, like what is happening? Lena, what is happening? She's the one.
Like what? You need to select second.
How to
third.
select second, third, and fifth?
I put in another bracket. So.
Oh, okay. This is what I would do because I don't remember what I did normally. So I would write like this. What was it? First,
One,
two and four, right?
Yeah.
I don't think it works, but let's give it a try. Woohoo! That's how we do it, right? You just start with the first. By the way, comment out the second line. Experiment first. Start with the things that you understand. First try the line that you know what will output, right? And then try to expand on top of that. Now that we know what to do, Simon, you know what should be done here.
Yes.
Tell me what should be done here.
So let's copy the first line.
Okay, as you wish.
Thank you. And let's put in the second squared brackets, we can put 0 and 3 instead of 0, 3. And this is it.
Wow.
I think it will work.
Yeah, I think so too. What I would do is I would print out the result just in case of both of these data frames, just to make sure that what we have done makes sense. Okay, so the first one has 2, 4, 3, 5, 5, 5. Let's see, 2, 4, 3, 5, 5, 5. And the other one is 1, 2, and 4, 4. So let's give it a try. Here is my function, a beautiful function that should output, it should color them. Yay! So now what happened is that I gave these two data frames into this function, and I colored the training in a green color and the test in the blue color. All right. And yeah, that's pretty much it. I just want to check that this was the correct indices that I wanted to keep. Otherwise, do you guys have questions so far? Yeah, I think I made a mistake. I made a small mistake. Let me just go back to my code here. Ladies and gentlemen, just a tiny mistake, because we have done in the lecture slides, we had something else. We had other two points as a test set. We had second and fifth as a test set. So let's make second and fifth. So here it's a second and fifth, and here it's first, third, and fourth. Okay, so it's 0, 2, and I guess it's then 3, right? Yes. And here it's 1 and 4. So change that just to be the same as in the slides. And then we can run that and get exactly from what we had in the slides. Because you remember that this is what the point that Simon just looked at this and he said 3.2. This was the point that we were looking at. So he was saying that the second x equals to 2 and 4 as a y-axis. Just to be consistent with the lecture slides. Can you guess what happens now? Simon, what happens now since you were the one to help us through this?
What happens now? Now, I think we are ready to build the model.
Yeah, we are ready to build a model. So what happens is that we import linear regression, lasso, and ridge, and we build them. So for lasso and ridge, we use lambda equal to 1. And do you guys remember how do I build these models? Olena, do you remember how do I build these models? So for example, if I want ridge with lambda equal to 1.
Just call ridge function.
Okay, just ridge. And what is inside?
Put our data.
So
Lambda.
Yeah, lambda. I can also write lambda, but then I need underscore of the lambda to just make sure. So this is a constructor. So this is something that just makes a template of the model, right? Just creates a template that we can later use on our data. So this is not the real model yet. It's not yet trained on our data, but this is a template. Of course, the other one is also lasso and then also lumped. It's again, it's a template. It's not a, so template, okay. Oh, we can run this. You see, it takes no time. It takes no time to run it. It's exactly because it's just like a factory. It just produces these templates with a specific lambda. Now what I want to do is I want to train these models on a training data and against, so I want to train it on x-axis against y-axis of the training data. I think I should have removed it from all the places. Basically what happens here is that I want just to copy all these things here and here and here, okay? I take a linear model or a ridge model or lasso model and I train it on x-axis of the training data against y-axis of the training data. Does it make sense? Ladies and gentlemen, does it all make sense? Okay, I can see that Kenneth is saying yes. Can't hear it, but I could infer. I can infer. I think everybody, Olena, could you speak up? Does it make sense? Does it make sense to you?
Yes.
Are you sure? This doesn't sound too confident, but it could be just the distance from Canada to Tartu, a bit distorted signal. Okay, you would be able to repeat if I ask to build a model, then you would know what to do, would you?
I hope so.
Okay, we will check. Trust me, we will soon check. So what happens is that I just run this and I get, okay, I get error. So what happened? What happened? Ladies and gentlemen, what happened?
You didn't use fit method.
I didn't use fit method. So it wasn't just copying, right? It wasn't just copying. So I didn't use fit method. I had to use fit method to train stuff, right? This is what training is all about. It doesn't just, so the object itself is not a function. Fit is a function, but fit is a function that is stored inside the object. Fit is something that is, so I'm not sure if you guys had a course on object-oriented programming, but basically you have an object like elevator. Elevator has, it has functions. It can go up and it can go down, right? When you press the button go down, it starts to close the door, and then it goes down. So LR bridge and LR lasso, these are these complicated objects. They have attributes and they have functions, they have methods. So attributes is what describe the object. It can, for example, it can say what are the coefficients of the model? What is the name of the model? What is the, I don't know, what other attributes you have about the model? What could be the attribute? Simon, what could be the attribute of the model? Like, I think name is okay attribute. Well, this is what describes the model. Like me, myself, I have an attribute name, which is Dima, right? But I also have a method. I have a method teach and then brackets. I can, if you put a name of the subject inside, then this method will teach that subject, right? So then you can put teach into the brackets time series. And even if you don't know much about time series, you're gonna teach time series. You can put advanced machine learning and that will be a advanced machine learning. In terms of linear regression, you can put the data and it will learn this data. So this fit is a function, is what the linear regression does. It's what it does. It's how it works. If you would love to have attributes, then attributes usually have this underscores at the end of the name. So for example, Olena, do you remember what was the name of the, how do you get the coefficient of the linear model? What's the name of the attribute?
Coef and
Coef underscore, right? Coef underscore, this is an attribute. But if you have, if you don't have a underscore, then this is a function that is implemented inside the object. All right, so we have trained these models. What happens then is that we take this figure. It has a name figure, very descriptive, very nice programming style. Usually programmers try to make their names very unique, but I just made it figure. So what I do is I take that figure and I add lines to that figure. I just add lines to the same figure. So let's see how it works. I just take these models that we have trained and I draw them on top of this figure. And this is a humdrum example of 3 linear regressions that we have seen in the lecture, right? The dashed line is the linear regression. The red line is a ridge regression, and the blue line is a lasso regression. Now we want to test. So we want to know what are the predictions for each point by each of the lines. So this is what Simon did by just looking at the slide. Scikit-learn needs to calculate, right? That's the difference, a human intelligence and dummy computer, okay? Human just looks at the thing and like, okay, this is 3.2. Computer needs to calculate. So this is how we calculate. Olena, what do I type in here?
LR. Okay. Underscore reach and dot predict. And the same test underscore.
Yeah. Okay. Then I can do the same for lasso, right? I would type LR lasso and then predict. Looks good. Ladies and gentlemen, all is nice.
Yep.
All is right. Let's run this. Seems to work. Seems to work to me. But I have a comment here which says that we need to reshape the resulting vector. So let's see what are these results. Let's just print them out. So let's create another cell and let's print out all these predictions. Simon, what are we expecting to see when I would print them out?
The predictions, the array of predictions.
How many?
Or list of predictions. 2.
2 for each. Yeah. So let's see. So we have 3, 1, 4, 5, 5, 5. I think this was the things that we calculated. Somehow this is 3, 1, 4. Not, what was it that we calculated? 3, 1, 5, I think. Oh, 3, 1, 8. Anyway, 5, 5, 5. Okay, this is, and you can see that these guys, if I would print out not values but shapes, if I would print out a lar pret dot shape, what does it tell me? Oleg, what does it tell me if I would print out shapes? So what is the shape?
Shape, it's dimension of the array.
Can you predict what will be printed out right now for each one of these?
For predict LR, so we had the 3 rows, as far as I remember. Yes, it will be 3. And predict it's only 1 Y 3 1, I expect.
For all 3 of them?
No, for first one.
Okay. What about the second one?
For all of them, yeah, sorry.
Kenneth, do you think that these shapes will be a 3, 1 for each one of them?
I don't, but I'm trying to determine like why my intuition is saying that. I don't know.
Okay, but let me, Oleg and everyone, look here. So what if I print out only predictions for linear regression? I print out only predictions only for linear regression, just for sake of testing. Here is the prediction. Here are the predictions. So I just want to ask again.
Yeah, sorry, we had test. Yeah, sorry, it was test data set. So it's 2, 1, yeah, sure.
Okay, 2, 1. So let's see. Olena, are you agreeing? Do you agree with Oleg that this will be the printout of the shape of this vector here would be 2, 1? What is 2?
2 axes.
All you need is here. All you need is here. There are no axes here. Just what is 2 and what is 1? When you look at this printout, what is 2 and what is 1?
2 rows and 1 column.
Exactly. 2 rows and one column. This is what happens. Let me print out and make sure that this is indeed 2, 1. But now my question is, let me print out lasso predictions. Oleg and everybody, lasso predictions. This is how they look like. What would be the shape? Olena, what would be the shape?
One, 2.
1, 2, because there are 2 columns and 1 row. If I do it, here we go. Well, 1 and then, I mean, 2, 1, meaning that it's just a vector of 2, basically. That's what it's trying to say.
Yeah.
It's trying to say that this is, yeah. There is a problem with this kind of stuff because all the others, if I would print out shapes of all the others, they would be 2, 1, 2, 1, and this would be a vector of 2. This is a problem. And we need to solve that problem because otherwise all the functions will not work the same way for all 3 vectors. So what I propose here, I write, we need to reshape the resulting vector. So what do I mean by this is a function called reshape. The function called reshape, which is basically taking a tuple. Simon, do you know what tuple is?
Tuple, yes, it's a data structure in Python.
So how many values there are in tuple?
As much as you want. Tuple, no? It's a line. It's like list, but you cannot change it.
It's like list, you cannot change it. But what if I want to change the shape of this prediction here? So we see that the shape right now is 2, just 2. 2 values, and I want to make it look like this. So I would just write 2, 1, and then I will print out the shape. And you can see that I can actually do this kind of very violent things. Like I can write a variable name, then dot, a function, and then another dot and another function. And this will be working in a chain. So it will first take a reshape, and then it will take a shape of the reshaped version. And also note that I have two additional brackets inside the reshape. And this is to infer that this is a tuple. This is just to say that this is a tuple. Tuples cannot come without additional brackets. Okay, this is the complicated part. This is the Python it's complex stuff. It's a complexity that comes with Python. I don't like it myself, but here we are. And now you can see that basically we have 2, 1 for each one of the predictions. So what I do, I change this right after the predict. So whatever I predict, and then I put it through the reshape. And now if I rerun the predict part and I remove this reshape from here and I rerun it, I get 2, 1 for each prediction variables, shapes.
So it seems like it's a bug of consistency in scikit-learn, yeah?
Yeah. So sometimes you got to deal with this kind of stuff that wasn't fixed by some 7 people that maintain scikit-learn. Let's have a break.
Now I think it's already a back compatibility issue, yeah, that they cannot change interface because.
Yeah, they will have hard times fixing that one. Let's have a break, everybody, and come back in 10 minutes in 10:32. And if you guys want to ask questions, I'm here, but otherwise go and stretch your legs and walk around a little, get some tea, coffee, and come back in 10 minutes.
Okay.
What's the utility of tuples? Why do tuples exist?
Oh, that's a very good question. I don't know, to be honest, because in R we don't use tuples, and
I can.
Oh, you can
help.
Okay.
Yeah. So the main thing why we use tuple because it's unmutable, immutable. Yeah. So list is mutable data structure, so you can change it, but tuple is immutable. Yeah, you cannot update it. So it's, let's say, very specific thing. Yeah, but if you really make programming, yes, that it make big difference. Yeah. So how the data is stored in the memory? Yeah, how do you handle it? Yeah.
So when you want to freeze the order and structure of data, that's what it's for. So that gets manipulated later on. Exactly the same.
Yes, this immutable is a keyword in this case.
And so I guess so is that because it's a common problem? Is you accidentally changing data or something like?
Yeah. So
a side effect that happens.
Yes. It can. So Python, let's say, is a generic purpose language, and it provides you the choice, yeah, flexibility. So in some cases, you want to change it, yeah, then you use lists, yeah. In some cases, you don't want to that somebody change it, yeah, accidentally on purpose, then you use tuple. So this is a.
And it has nothing to do with the number 2, basically. Because
is what?
Because when I see it, I always hear like 2, like the number 2, like 2 pairs. But actually, it doesn't have anything to do with pairs of things.
This could be more than 2, yeah.
Yeah. Okay. All right, that's actually a good explanation. Thanks.
Yeah, thank you. That's definitely something I didn't know.
I shall get myself a glass of water.
Good. Go ahead. Me too, actually. Welcome back, ladies and gentlemen. I hope that everybody's back. Igor, are you around? I can't check right now.
Well, actually, I'm here, but I can only hear, and I can't participate because on a different computer I have a call from my work. So
Gotcha,
like
gotcha.
yes
Don't worry.
and no. You know.
Don't worry. Try to just to kind of be aligned with what we are saying. We're discussing on the code, so it could be very useful.
I'm following the screen, and I think I will catch up to this.
Good.
Thank you.
Good. I'm actually happy to give a talk about autonomous driving, but we don't have much time, to be honest, in both in terms of this lecture and the time series lecture. But let's see. Oleg, we can talk about this separately as well.
Yep.
So coming back to the code, we just make sure that all the predictions are the same shape. We fix the bug. Nice. Now, what I want to do is I want to compute the RSS. Who remembers what RSS is? Olena, what the RSS is? What RSS stands for? Any wild ideas? Anybody?
Alex, you have right, this residual sum of squares.
Yes, I've written that this is a residual sum of squares. So, so what is, how do I calculate the residual sum of squares? So I have predictions and I have true values. These are vectors, right? So these are the vectors. So what I usually do, I get stuck and I'm like, okay, so what do I do now, right? So I know what the residual sum of squares is. I can take, for example, all right, so let me try this. I can make it even bigger because I really liked when it was like super big, very bold, and everybody could see it. All right, so what I usually do, I get somewhat stuck. I think about this and I stuck. I don't know how exactly this is implemented in Python. And then what I think you guys sometimes have, you also maybe get stuck and you don't know how to implement that or another thing. But what we could do is we could take, for example, linear model predictions and take a look. Now the question is, where the true values are stored of the test set. The true values of the test set are stored. Simon, where the true values of the test set are stored? Which variable?
True value, it is in the another data frame. It is in the test data frame.
Test data frame, .y, right? Because that's what that's the trick of the data frames. I can just put dot and then the name of the column, and this would be the values of true values, right? This is what I wanted to predict. And this is what I got. So the residual sum of squares, as far as I remember, and as far as the name tells me, right? If I listen to the name, it's residual is the difference between what I predicted and what is supposed to be there. So I can just say minus spread. This is just for myself. This is just for myself, just to write it up. Of the first value, right? Squared. So I don't know how you guys used to write square, but I used to write it like this with a hat. And then plus the same stuff for the second point, yeah? So this is what the residual sum of squares. The residual is inside. This is what residual is. Yep. This is squared, and this is a residual sum of squares. This is RSS, okay? RSS. Now, but these are the individual points. This is like predicted value 2, which is 5.5. This is 5. So these are individual points. What if I want to have vectors instead? What if, for example, I just take the true value, I subtract the predicted value. What do I get? What would be the vector? Olena, what would be the result of this operation here? Everybody? Semyon, how about you?
So if we have two arrays here, then we will have an array with the difference of the elements.
Can you tell me?
Okay. So it will be 0.86 approximately, and 0.5.
Yeah. Olena, how do you get 0.86?
Okay, 4 minus 3 point. Okay.
Yeah, and 5 minus 5.5 is minus 0.5, right? So what I expect here, well, I trust Semyon. Who cannot trust Semyon? I don't get that. So I trust Semyon, and I expect to have a column which would have 0.86 and minus 0.5. So this is what I expect. But instead I get the error message. Don't worry, I don't know what the hell is that. Data must be one-dimensional. It could be that we need to write, so I know what could be the trouble. So I just, I somehow sense the trouble. So I sense the trouble with the data frames that sometimes when you use dot name, it actually outputs not the vector, but some weird stuff, which you wouldn't be able to work with. So instead I use this notation. It's a super weird, uncomfortable and inconvenient and weird notation, which seemed to work. This is how I remember it. It's extremely inconvenient.
I think in this case, what you're doing, yeah, you're taking, I think it's called test series from dataset, and in this case, it's vector. So,
yeah.
So in fact, there are two data structures in pandas: data frame and this
series. Yeah.
Series, yeah. In this case, it's series vector, and then you work vector with vector.
Yeah. I think previously this was series, and this is now vector, right? So when I say dot name, it gives me series. When I have this double pair of brackets, it gives me a vector, which I can then use for all purposes that is required. Olena, I'm really sorry for that, but I won't detach very easily today. I really want us to develop a very solid understanding of what is happening. So now that we get this vector here, what is it that which part of this line here, this result corresponds to? So if I take 0.857, where in this line here, this 0.857 would come from?
This in
What are you saying?
this in first bracket, this.
Yeah, this one, right? So I can just write 0.857. Oops, I can't, sorry. So instead of this, I can write 0.857. Well, should I ask, or you can guess that this is minus 0.85, right? Oh, sorry, it's minus 0.5. So my next question is, what if I put a square above these stuff? So
no, there's no summing yet.
There is no summing yet. There is no summing yet.
So can we do sum, bracket the whole thing, and then cube it?
Okay, so so what Kenneth is saying, can we guys sum this up? Can we sum this up? Oh, we can sum this up, and then we can take a square on top of this.
That's the square of the sums, not the sum of the squares, though.
Exactly. So what I propose is that we first square up. So we take a square And then we get the vector of squared residuals, square differences. Olena, can you see where this value comes from?
Mm-hmm.
So this is the result of this operation. And this value is the result of this operation here. What is left? What is left, ladies and gentlemen? What is left? There is one little bit left. So now we have this value and we have this value. What is left, Olena? We can sum them up. Yeah. Like this, right? And now please implement RSS down here. And raise your hand or give me a sign that you're done it. You can raise hands by clicking on participants and then like doing this or doing this as well. This also works.
Shall we test it on our side whether it's working?
Yeah, test it.
Right.
Sure. Test it. So I just wanted to, I think it was for those of you who had trouble with the first homework as well, that this is what I do when I get into trouble. This is what I do when I try to implement something that is a bit more complicated than my primitive mind can imagine straight away. I don't know how the Python works inside. So I need to really start from scratch, start with the primitive ideas that I know they work. Like I can print out stuff. This is the toughest it gets for me. I can print out stuff and I can see what is inside stuff. Then I can, let's say, subtract one stuff from the other stuff and see what the printout is. Then I can, I don't know, whatever, do the square, sum them up, and see what the result of these operations. And then I can put them inside functions. This is how I approach a programming part of all of this. I'm not good at programming pandas and NumPy, but this is how I do it. And of course, a lot of Googling, going to Stack Overflow here and there all the time. Olena, have you done it? Mm-hmm. Can you tell me what should I type here?
Predict. Oh, okay, so I forgot about this.
Predict. Predicted. Okay. Simon, can you help? Can't hear you. You're muted.
Predicted minus true double square.
Stop. Elena, what happens then? So predicted is this thing, right? And the true is this thing. So we can actually reverse it, but it doesn't really matter because we take a square anyway. So true minus predicted, what else should I type? So look at this line here. Look at this line. right? So it's has a square, and the different. Sorry, can't can't zoom out. I'm really sorry for this. Yeah. So this line is equivalent to what has to be inside this line here. It's just the names are different. So what should be the next operation here? Lena, what should be the next operation to this difference? Huh?
You need to square it. Like,
You need to square it, absolutely. So I just square it. And?
sum up.
Huh?
And sum up.
Can't hear you.
Sum up.
Sum up. Exactly. Ta-da! That's all.
Do we not have
Need to?
We don't have to put the square brackets for the true. That we won't have a problem with the shape. No.
Oh, but I think basically if you put this inside the RSS, so let's do it.
Sure.
So what we do, we call the function, and then we have to give predicted and true, right? So we first give predicted, which is Oleg. What is the name of the variable for the linear regression?
A letter predicted.
A letter pred. And for the true, we will use Simon.
We'll use test.
Test df, right?
Df.
And then double
Y.
square y. Okay. Lena, what would we write for the ridge, for the case of ridge regression? For the predicted. We can't hear you, you're muted.
Okay. LR right, which Боже, sorry.
Ridge, pred, right? I think I had. And then here we just, what do we write for the second one?
It's the same test.
Yeah, same test, same. For the lasso, I guess I won't ask you guys more. It's just the lasso brand. Now it should be good, right? So
No.
if we what? Oleg, you were saying.
Yeah, when I debug it, actually didn't work for me, and I had to convert it to NP array.
I think you haven't added this part here, did you?
Yes, I did. Okay, doesn't matter. So I see that it's working. Just I will check afterwards why it didn't work.
Yeah, but I'm doing NP array, but only here. All right. So what can you say about these results, Kenneth? What can you say about these results?
Pretty bad. They're pretty much identical, which means that something's gone wrong here. Oh, I know what. Sorry. I copied and pasted because the format was the same, but I haven't yet finished the changing. Sorry. What can I say about the results? Looking at yours, the mathematical results or the results of our programming?
This stuff. So the RSS.
Yeah, that's a pretty wide range, and so I guess now we're going to do some ensemble learning and take some average.
Yeah, but so which model performs best?
Oh, the linear regression.
So which one?
Linear regression.
So RSS is a measure of what? Is it the
0.61?
Sorry?
0.61, ridge regression.
So let me ask you the question. So residual sum of squares, the better a model, is it that the RSS is bigger or the RSS is lower?
That it's lower.
Yeah, so the lower the RSS, the better the model.
Yeah.
So 0.615, right?
Yep.
Which is a ridge regression. So the ridge regression in this very particular case performs better than the rest of the models. and the lasso regression performs the worst. Okay, can you guys see this? Everybody? So when I ask in the homeworks and the homework exercises, I ask you to interpret. It usually means that I ask you to look at the values and tell me something that, what is it that you see? The model is better, the worse than the what, than the baseline, then what kind of baseline, how do you know, and that kind of stuff. So if you could tell me that kind of stuff, that would be, this is what I'm usually looking for. Now, let's combine predictions of 3 regression models into ensemble by averaging. Oh, they're in a different number, sorry for that. By averaging. So how do I combine predictions by averaging? Simon, what do you think? How do I combine predictions by averaging?
So you take the prediction and calculate average. Take prediction for every model and calculate average.
So what if I just write rich bread, LR lasso bread? Any ideas? What should I type in here?
Mean.
Mean.
I mean.
Yeah, just. So where the mean comes from? Which mean? Can I just type this? Would this be fine?
I think NumPy, no? NP dot.
This would be fine, ladies and gentlemen.
Let's try.
Let's try. Exactly. Let's give it a try. So what is happening here? What is happening? Only integer scalar arrays can be converted to scalar index. So what I usually do when I get this very so just to give you a bit of context, I told you, right, that I like R, and so people that program in Python, they usually make fun of people who program in R. And one of the most frequent thing that people that program in Python say about people who program in R is that R is very terrible at giving insightful error messages. This is what you will hear a lot about people who program in R. I would say that this message is as insightful as any other messages that I have seen. So it doesn't tell me much about whatever stuff. Only integer scalar arrays can be converted to scalar index. I have no idea what this means. So what I do, I go to Google and I say, hey, what the hell this message is all about? So I go into Stack Overflow and it says type error, scalar 1D NumPy indices, blah, blah, blah. And so it says that something that is a list, not a NumPy array. You cannot use array indexing on it. Make it array first. And that is something that we can use as a hint, or maybe this. So maybe we should have some kind of array. So what could be is that we need to have this stuff as array. Let me give it a try. Okay, now we have one value, 4.1. So I just put the brackets around these predictions, made it into a NumPy array. This is how you usually do it, or just array. And I got one value. Kenneth, are we happy now? That worked. There is no error message. Should be fine now, right?
No, it's you need to. There's something wrong because the value is very far away from the kind of range of values we had before. It does not look like the mean of the previous ones.
I guess it is. I mean, look at these. Okay, so Kenneth is saying that there is something wrong with the value. Okay, so these are the ranges. The 3, 5.5. If you look at the reach, it's again 3 and 5. Sounds right to me.
Okay.
Are we happy? Looks good. Looks good. Oleg, are you happy with this value?
To be honest, not, because I don't understand, let's say, rationale behind why we shall.
In fact,
why average is better? Yeah. So in this case, let's say like this.
Let me ask you this question other way around. What is it that we are trying to get?
we are trying to get average prediction for 2 points.
2
not
points.
Not for 1
not
point.
Not 1 point. But
so it's
2
average
points.
Average for 2 points. We received average for 2 points.
Okay. So you mean from?
We get one value, but we need to average up predictions for each of the test points. So this is a test point, and we have 3 predictions, and we need to average 3 values and get 1 average value prediction for this point, 1 average value prediction for this point. And now we have just 1 value. So this is definitely not something that we were looking for, right? We were looking for 2 values, 2 averages. The averages of these predictions and averages of these predictions. Does it make sense, Kenneth? Does it make sense?
It does. I have, I'm slightly distraught because my RSS, in my code, I'm getting slightly different numbers. I am trying to find the origin of the differences.
Please, you can copy these things.
Yeah, I have, but it doesn't. For this part, for the ensemble prediction, I'm getting the correct number. For the ones beforehand, they're getting different. For somehow it's solving itself. It's okay. We'll continue. I'll just look at you.
Okay. Maybe we shall help. You can maybe share your screen and we can try to point out the error.
Yeah, sure. Why not?
I'll stop sharing mine, then you can take over. Okay.
Yeah, so
these are quite different.
Yeah, and I can't find, but this number here is the same.
Yeah. Okay. Let's go up. This is fine. Wait. I guess. Wait. Go down. So in the RSS function, you do sum first, and then square. You need to first square and then sum.
Okay. Excellent. Thank you.
Let me share my screen.
Oh, how do I get out
You can stop sharing because I can't take over. Okay. So otherwise, Olena, do you see why we are unhappy with this value, with 1 value? What is it that we were looking for?
2 values?
We were looking for 2 values. So the way to get 2 values is to specify axis along which we want to take the average. So this thing, let us print it out and check it out. This thing will be, will have a very weird shape. Wait, let me see if it works. Okay. It doesn't have shape because it's not a NumPy array. So let me make it into real NumPy array. Okay, it doesn't work this way.
Brackets.
Yeah. So shape. So this is true, 3 by 2 by 1, right? 3 by 2 by 1. Lena, what is 3 in this? So if I print out shape, it says 3, 2, 1. We saw that each prediction has a shape 2, 1. So what is 3?
3 predictions.
Number of predictions. So this is now called, how do you call this matrix that has more than 2 dimensions? Ladies and gentlemen, how do you call matrices more than 2 dimensions?
More than 2 dimensions.
It's called tensor. That's why you have a tensor flow. It's because there are flow of tensors. They flow from the start of the network to the end of the network. It's called tensor flow because they're tensors. Now we have a tensor 3, 2, 1. And just to remind you, this is how it would look like. How do I, okay, let me put it this way. What is the axis by which I should take average? Okay, what is the axis by which I should take the average? There are 3 now, 3, 2, and 1. What is the axis by which I should take average? I can take average by 3, then I will have how many values?
3. 3.
3? 3? 2. You will have 2 values. Look at this. Basically, this is hard because this is tensor. It's not matrix. It's a tensor. It has this is just this 2, 1. This is one prediction. This is another prediction, and this is the third prediction. So taking average of by the first axis, we'll take average of this value, and this value. This would be one value, the average of first values inside these predictions. Then we would take also average of this, and this one, which would be the second value. So let's just see how it works. So NP mean, and then axis equals to 0. So this is the first axis by which I get 2 values, right? Ladies and gentlemen, I get 2 values. Olena, how many values I will have if I would average by the first dimension? But I mean, when I say first in Python, I mean second, right? So you just remember that. Just to remind you that the shape of this thing is 3, 2, 1. So if I take